I should like to bring up an astonishing experiment on color vision, published by Edwin Land in 1959. Land showed how a multivariously colored picture can result from mixing only two primaries. On the basis of this finding, he proudly declared, "We have come to the conclusion that the classical laws of color mixing conceal great basic laws of color vision." How could he claim that? Let us discuss the experiment in closer detail. You are probably familiar with the method of color reproduction by help of so-called color separation. The scene is photographed through a red, a green, and a blue filter, and when the three positive black and white transparencies are projected onto each other through their respective filters, the colors of the objects of the original scene are recreated. This method of color photography was suggested by James Clerk Maxwell in 1861. He was also the one who verified the so-called trichromaticity of human color vision, which is the scientific basis for this kind of color reproduction. The method is still used on our computer screens, mobile phones, digital projectors, etc. Anyway, let us return to Edwin Land. He skipped the blue record and projected the green without a filter. Still, he obtained the full gamut of colors. From the laws of additive color mixing, you would expect only various shades of rose, something like this. So how could one possibly get a variety of hues in the projected image? Let us look a bit further into this. Here is a digital reproduction of a postcard picture. As I just said, even modern digital color reproduction builds on the color separation method. So, on your screen you actually have three superimposed images, a red, a green and a blue one, which by optical mixture constitute a picture in full color. In order to simulate the Land experiment, we cannot manipulate the filters, of course, since they are built into the equipment, but we can manipulate the data. By letting the green record take over all three channels, it appears on the screen as an image in black and white, as if projected without a green filter. Next step is to superimpose this with the red record. Let us see how it turns out. We start with a neutral image and then let the red one successively take over more and more. We immediately get a multiplicity of colors, which persists within a wide range of mixture, all along to deep red. Here I have chosen one typical example. What do we see here? I, for my part, see various hues on the objects, especially the dark blue box in the red boat and the green side of the second boat are intriguing. Observe, however, that I am not asking what colors you see on various spots on the screen. I am asking about what colors you see in the picture displayed on the screen. It is a huge difference. Perception psychologist James Gibson says, "What is a picture? A picture is a surface that always specifies something other than what it is. The picture is both a scene and a surface, and the scene is paradoxically behind the surface." These are the possible colors presented on the screen. There are no other colors than a selection of these. but as soon as they are arranged in a pattern of areas on the screen, you begin to see it as a picture of something, and then diverse colors make their appearance. Color researcher Michael Wilson and his collaborator Rafe Brocklebank made a striking illustration of this. Select 36 typical colors from the given palette and arrange them like this. Not very spectacular so far. But let us fill in the dark spaces with an unsaturated color belonging to the same rosy scale. The layout immediately turns into a display of color samples on a common background. The more I dwell on it, the more it looks like colored paper samples seen in a reddish illumination. This is called object color perception. It is really an astonishing variety of subtle hues. But let us return to our boat picture. Even this can be regarded as presenting colored objects in reddish illumination, say from the setting sun. When I look at it, I see the colors, so to speak, through the reddish light. I see them as they would probably look in neutral light. Referring to the Wilson and Brocklebank demonstration, it seems reasonable that one may see the unsaturated areas on the screen as blue-green, but it is still not clear why the box in the red boat should look blue and the side of the second boat green. There is no physical information indicating this split up of blue-green into blue and green, because that information is normally supplied by the record in the blue channel, which was deliberately left out in our study. So we are dealing here with an indeterminacy in the optical image, leading to a perceptual ambiguity. The fact that you nevertheless see the picture in a certain definite way reveals that color vision is an intentional act. Color doesn't force itself upon us. It is up to you to accept it in its own reality. True reproduction was not Land's point. The point with his demonstration is simply the fact that a sufficiently intricate picture is capable of creating its own color universe, according to which basic laws of color vision still remains an open question.